Okay, in order to use this Passcode Capstone product, first, Passcode Capstone. What's nice about this is it takes your data for you as long as you set it up right. I'm going to recommend you to use the 4 or the 2 small, 1 large display. Um, so in order to upload a movie, so you click on these icons here, in order to upload a movie, it has to be downloaded onto your desktop. Like it has to be on your computer. You can't, if you did it on a phone, you can't just pull it straight from your phone files. It has to be on your desktop or in like your physics folder. So when I opened this movie file, it's saved on my personal files under Unit 4, horizontal motion. This is a video I took before. I will have a link to 2 videos for some of you guys. The videos will be on Google, which means it's not on your desktop, so you're still going to have to download it. Okay, so this video, a nice shot of one of my bathrooms, sorry about that. When you're dealing with this video, a lot of setup time, so if you press play, it's going to be a little bit before the car moves. Then the car gets pulled back and releases across the screen. So you're testing the acceleration of this car. In order to do that, if you notice there are all these icons across the top, I want this crosshatch. This is going to turn this into video analysis mode, and it's going to give you an axis. So it'll give you one of the coordinates, and then it's going to give you this calipers. If you see this, this calipers is how it'll measure what a distance is. So I didn't have a meter stick, so this is a little shy of a meter, but this thing, notice it says 1 meter. So that's always I'm going to go a little bit longer. This is always kind of your baseline is 1 meter. You can always go ahead and change that. If you wanted to change that measurement around, you could. And I'm going to flip this over just so that it doesn't really matter what direction this is. Um, Also, if you notice it's much easier to run your data from left to right because it's moving in a positive direction. Now, when we do free fall, you're going to notice it doesn't matter. It's just going to fall. So that's what we're going to use. Okay, so again, the calipers tells the system, the computer program, that this is about a meter. As you can see, I can go in and edit this. I could change the unit, centimeter, and feet, and I can change the number. But we're going to say this is about a meter. It's a little off, but at least it gives us something to work with. Okay, before I start taking data, I want to put it in a table. So I'm going to put a table in here, and the x coordinate is always time, and the y coordinate is going to be object 1. And in this case, we're going to do distance. Okay. And we'll do this one too. We'll do another table, and this one's going to be time again. And what's cool is on object 1, you can also measure its velocity. Note it does all the work for you. Pretty cool. Now notice my play buttons went away when I turned on video analysis tool, and make sure this still says object 1. If you do lots of clicking, it might change to object 2 and it won't collect the data that you want. So now I'm going to kind of rewind my video. Notice here's where the thing runs to. Sorry, or runs from. I want to start the video exactly where I'm going to kind of forward arrow this. As soon as you see me release, or as soon as you let go of the vehicle, that's where I want you to start tracking. And then up here across the top in this video analysis mode, right next to object 1, there's an X which says delete active object or create tracked object. So I'm going to click on this. I'm going to make this back to object 1. And I'm going to pick one spot on this vehicle that I'm going to continuously track. So for the ease of this, I'm going to choose the wheel. Okay. The first click will bring you back to the picture, and the second click will mark it. So notice there's a little red X. Then I would say jump, using the double arrow, jump about 4 or 5 slides. 1, 2, 3, 4. It already advanced 1 slide. And then go ahead and mark it and try and do the exact same place. 1, 2, 3, 4. And notice if this vehicle is in fact accelerating, the dot should get farther and farther away. 1, 2, 3, 4. I don't think it advanced 4 there. The vehicle is going to get harder to see. 1, 2, 3, 4. I'm going to mark it again. 1, 2, 3, 4. And if you notice, if you mark this straight up, it's going to start recording data for you. So I can't even tell where the wheel is. It's going so fast. I'm going to eyeball it and give it my best shot for the rest of these. Okay. And at some point, I think this cart is kind of a cruddy acceleration cart, so I don't think it continuously accelerates throughout the whole process. Okay, but it is still accelerating at this point. Okay, here's another one. And can I get one more in? No, the wheel goes out of the picture. Okay, so we have these wonderful data points. We have the instantaneous velocity here. This is going 0.31 meters per second. It's traveled 0.1 meters. So gives you an idea. Starts at 6 seconds in. So ideally, we would try and take this down to 0. The final thing we're going to do is put in a graph. That kind of clicked it for me, but you should have the option to choose the graph. Always on the x-axis, as you learned on the trip, is time. And in this case, let's do a position over time. So notice we have, because it's accelerating, we have an exponential curve. What's cool is you can kind of get the line of best fit here. So the slope of this is about 1.6 meters. That's going to be 1.6 meters per second at this time. So you can kind of bring it down and you can see where it's slowly accelerating. And this is this tangent line. Oops, don't want a second one. This you can also get this is another way you can solve for this. You can select some points and get the slope of the total space. So this is picking a really random slope. I can actually take that off. Apparently, there it goes. So what you can also do is you can go ahead and change this to the velocity. So as you can see, it's continuous. The velocity thing is continuously accelerating. So this might be where you want to pull in your slope. So about 1.5 meters per second is the acceleration. Remember, velocity over time is acceleration until the very end when friction gets the best of it and the spring and the wheels aren't working with it. Okay, so you're doing this for the buggy. I have a video of the buggy and a video of the fan cart. The fan cart is an acceleration. I did it on the middle level. Okay, and then the buggy should be a constant. So if you see the buggy lab, it should be, if you do a velocity over time graph, it should be a straight line, ideally. If you did a distance over time, it should be a constant positive slope. Keep that in mind. It's important that you kind of walk through these steps before you shut this down. Please, 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 please make sure you take a screenshot of this. So, let's do one of each. So I'm going to have you make sure you title your tables. I don't know why this doesn't have a title. Wonder if I can make this a little bigger. Oh, super annoying that it doesn't have a title. Oh, graph title right here. Make sure you title these and then use the snipping tool. Okay. And the snipping tool looks like and this allows you just to take a picture of the page that you've created. So I would say, oh, I don't want that email in there. Oh, well, whatever. And then save this into a Google Doc and please title this entire picture. So I'm going to say this is velocity over time of accelerating cart. Okay, save my picture in a way that I will remember. And then I might do a second one just for safety's sake. Oh, so that's wigging me out. Okay. So now I want to change this to position over time. And I would say take a picture of this too. So you're going to have a bunch of graphs. Again, I would take points off because there are no titles. No title, no title, no title. Ugly. Okay. So make sure you take the time to title those. And then I would save this. This is distance or position or time of accelerating red car. Okay, beautiful. Once you do that, move on to the next one. So you would say file. If you really want, you can save these experiments if you have your screenshot labeled and they look good. You know what? No, you have plenty of space right now. File, save each one of these so that way if it doesn't come through, or the picture didn't work, or you can't find it, save it. So that way you don't have to completely redo this experiment. So file, save experiment as, whatever. Okay, there's my saving. Beautiful. Do a better job with the name. I'm kind of in a hustle. Okay, new experiment. Same thing, 4 displays. Wish we could do 5 displays so I really could get all the data that you want. I kind of wonder. I bet you could. Let's see. 1. Problem is it's going to detract from the work that I want out of you, but let's see. I wonder. Can we do one more display? Ah, look at that. 6 displays. That'll work. Maybe try that with the next set so you don't have to do this so many times over and over. So this one will be the movie. I'm going to go open a movie file. This time I'm going to mess with, oh, that's why, last year. I'm going to mess with free fall. Physics. Oh, here's all your running labs. I could do that too. Okay, well, that might be an optional one because I have other things. Here's free fall. So I'll do a student video. Let's do it. I'll post a couple. I'll post a couple of them just in case this happens because we had this issue last year. Okay, open movie file. I'm gonna pull in my video, see if this one works. Ah, success. Same thing except this time it's free fall. So, unfortunately I didn't put a meter stick. If you saw that other picture, that young man did put a meter stick. I don't know what these markings are. I'm pretty sure that's about a meter. Right? And then I'm gonna set my here where it's about going to drop. Then I would advance the screen until the point where I'm ready to drop. So on and so forth. Do that, graph your data, do a table over here, do your graphs up top, and make sure you save all the pictures. All right, thanks guys.